Section 4.3, derivatives of the inverse trig functions. There is a PDF attached to Google Classroom Compliments of Mr. Martinez, where he has a big box on the very first page of the notes, and it has all the 6 trig functions laid out nicely for you. And he also does 2 proofs. I recommend that you at least look at the first page of that PDF and you write down the derivatives of all of those trig functions in your notes. They're going to be very, very helpful. So I'm just going to go through and I'm going to do some examples from the book, and this video should hopefully get you through today's, basically the whole week's lesson. So you are asked, I'm going to start with number 2, and you are asked to find the derivative of the inverse cosine of 1 over x. I'm going to do a little u substitution off to the side, and I'm going to say if u is 1 over x, then du dx is negative x to the negative 2. And that's going to help us when we're finding the overall answer. Okay, so the derivative of the inverse cosine is negative 1 over root 1 minus x squared. That is the derivative of the inverse cosine. Okay, so my x is now, so if it's like the inverse cosine of x, well, my x is now 1 over x. So I'm just going to do a substitution, and we'll use the chain rule, and we'll go from there. So this is going to be negative 1 over root 1 minus x squared, but x is now 1 over x squared du dx, and du dx is negative x to the negative 2. Okay, so this comes from, this is the definition of the derivative of the inverse cosine, and actually it should say here, dx dy. And that's where the derivative of quote unquote what's inside using the chain rule. Okay, and so from now, it's just a bunch of simplification. So this is now going to be, so again, I just did a straight plug-in into the derivative, and then instead of dx dy, I did du dx. The derivative of u with respect to x, the derivative of x with respect to y, and y is inverse cosine. So this becomes positive 1 over x squared. From here, this is x to the negative 2 is 1 over x squared, times the square root of 1 minus 1 over x squared. Okay, so I'm going to simplify the square root of 1 minus 1 over x squared. From here, it's just a bunch of algebra. There's no derivatives or anything else involved. This is just some, Algebra 2 honors work. Here we go. 1 over x squared. I'm going to kind of write pretty large so we can get a good idea of what this looks like. This is x squared minus 1 over x squared. Okay, so the derivative, the square root of root x squared is the absolute value of x. That's by definition. The square root of x squared is the absolute value of x. Can you see that off to the side? I hope so. Okay, here we go. So this becomes 1 over x squared times the square root of x squared minus 1 over the absolute value of x. Okay, this is the same thing as x squared over 1. Absolute value of x, always positive. X squared, always positive. So this breaks down to 1 over the absolute value of x times the square root of x squared minus 1. Okay, most of this section, if you know your inverse, derivatives, a lot of it's a bunch of plugging and chugging. Okay, I'm gonna look at, let's see, it's, not that it matters, it's number 6 in the book. What does it say to you? Y is equal to, this is number 6. And if you care, this was number 2, I think. Okay, so this says y is equal to x times the square root of 1 minus x squared plus the inverse cosine. Okay, it says s. The problem says s. I don't like s. S's and 5's often get confused. I'm going to use x. This right here, x root 1 minus x squared, has got nothing to do with inverse trig functions. This has to do with the product rule and the chain rule. So the derivative of y with respect to x. And notice there's no implicit differentiation here because I have all x's, so I'm not differentiating one variable with respect to another. All x's, all good. Okay, so x times the derivative of 1 minus x squared is 1/2 root 1 minus x squared, sorry. No, I'm sorry, I apologize. Power rule, decrease the power by 1, so it becomes negative 1/2 times the derivative of what's inside, which is negative 2x, plus the second, root 1 minus x squared, times the derivative of x, which is 1, plus the derivative of the inverse cosine, and the derivative of the inverse cosine, by definition, is negative 1 over root 1 minus x squared. I do not have any of these memorized. See, I have a little cheat sheet that you can't see. I have a little cheat sheet. I don't know any of them off the top of my head, so I have them written down on a little note card for myself, which you can do too. Okay, let's do some simplification here. So 1/2 x times negative 2x is negative x squared over the square root of 1 minus x squared plus root 1 minus x squared minus 1 over root 1 minus x squared. You would think with graph paper and lines I would write neater, but I'm not. Okay, so here are my common denominator already, so this becomes negative x squared minus 1 over root 1 minus x squared. And then I need a common denominator, so if the common denominator is root 1 minus x squared, this becomes positive 1 minus x squared. I multiplied by a common denominator. The common denominator from root 1 minus x squared to here, I multiplied top and bottom, so to speak, by root 1 minus x squared. Root 1 minus x squared times root 1 minus x squared is 1 minus x squared. Alrighty, so let's combine some like terms. And the derivative of y with respect to x is going to be negative 2x squared over root 1 minus x squared. And that is number 6. Okay, let's do something that's not just a plug and chug. Number 10 is asking you for equation of a tangent line. Equation of a tangent line means you need to know slope, and slope automatically means you need to know the derivative. So number 10 gives you that the, where are we? X of t, good, they're not using s. Inverse sine of root t over 4 at t equals 4. Okay, this doesn't matter. the fact that t is equal to 4, that doesn't come into play until the very end of the problem. So the first thing I'm going to do is I'm going to say this is the inverse sine of u, where u equals root t over 4. You don't have to. I think it makes it easier now. So therefore, I'm going to say u prime, because I don't know which letter I'm going to use yet, sorry. U prime is equal to 1/4 times 1/2 t to the negative 1/2, which is 1 over 8 root t. Okay, the derivative of the inverse sine is 1 over root 1 minus x squared. So dx dt, x, t, dx dt is equal to 1 over the square root of 1 minus x squared, but x is now root t over 4, times du u prime, which is 1 over 8 root t. Okay, again, once you get here, it really is just a bunch of algebra. There's no calculus involved. Once you do the plug-in, now it's a bunch of algebra. So dx dt is equal to 1 over, I'm going to write 8 root t, times the square root of, double square root, it's fine. I'll take care of it in a minute, of 1 minus t over 16. Square root of t squared is t, 4 squared is 16. So I didn't simplify it any further because I know t is 4. So rather than trying to go through the mess of the square roots and the common denominators and everything, I just plugged in at t is 4. So at t equals 4, plug in, and you're going to get 1 over, square root of 4 is 2, that's 16, times the square root of 4/16 is 1/4. 1 minus 1/4 is 3/4. So this is 1 over 16 times root 3 over 2, which is 1 over 8 root 3, which is root 3 over 24. And what do they ask you to find? They ask you to find the velocity. I misread the question. Okay, fine. Velocity is the first derivative. So my first derivative is this mess. I could have simplified it further, but it wasn't necessary because they gave me a value of t. It wasn't necessary because they gave me a value of t, which I'm kind of grateful for because then I didn't have to simplify this whole thing. Okay, let's do a couple more. Let's look at number 22. And all the problems that I'm doing mirror problems that you have to do for the homework. So let's look at number 22. 22 says find the derivative of y with respect to the appropriate variable. Okay, so 22 is y equals the inverse cotangent of 1 over x minus the inverse tangent of x. And they want us to find the derivative of y with respect to x. Okay. All right, the derivative of the inverse cotangent, is negative 1 over 1 plus x squared. So negative 1 over 1 plus x, which is 1 over x squared, then chain rule times the derivative of 1 over x. The derivative of 1 over x is negative x to the negative 2. Okay, minus the derivative of the inverse tangent. The derivative of the inverse tangent is 1 over 1 plus x squared times the derivative of x, which is just 1. Okay, so this is negative 1 over 1 plus 1 over x squared. Oh, the two negatives make a positive, so I don't need this negative right here. Times 1 over x squared. Well, this is nice. This is going to simplify out super. It's going to be very convenient. If you distribute, you end up with 1 over x squared plus 1. If you distribute, x squared times 1 is x squared. X squared times 1 over x squared is 1. Minus 1 over x squared plus 1. And this is going to be 0. Provided that x is not plus or minus 1. You know when you solve, like you're doing rational equations, and we say, oh, well, you get x is all real numbers except for, and you have to take care of the domain. So here the domain, x can't be 1 or negative 1. All right, last one I'm going to do, which I hope will get you through what you need to do for this week, is number 26. And 26 asks you to find the equation of the tangent. Okay, so I'm going to find the equation of the tangent at a specific point. Of course, the first thing I need to know is the slope, which is the derivative. I hope that by now you understand that slope means the derivative. Tangent means the slope at a specific point on a curve. Velocity is the first derivative. Acceleration is the second derivative. Jerk is the third derivative. Speed is the absolute value of the velocity. Those are all critical concepts. Okay, so y is equal to number 26, the inverse tangent of x squared. And they want to know what x equals 1. Okay, so I'm going to take care of x equals 1 later. First thing I'm going to do is find the derivative of the inverse tangent and then times the derivative of x squared, which is going to end up being 2x. Here we go. So the inverse tangent is 1 over 1 plus x squared. Okay. 1 over 1 plus x, which is now x squared, squared, times the derivative of x squared, which is 2x. So this is 2x over 1 plus x to the fourth. This simplification was easy. That's why I kept going. The simplification for number 10 was a royal pain. So that's why I just stopped and did the plug-in. All right, at x equals 1. So at x equals 1, the slope is 2 times 1 over 1 plus 1 to the fourth, which is 2 over 2, 1. Okay, that's the slope. And then at the point where x is 1, I got to figure out what y is. So the original function, they're telling me x is 1. So I need to figure out what's the point. Haha, what's the point? So if x is 1, this is the inverse tangent of 1 squared. And knowing your unit circle, the inverse tangent of 1 is 45 degrees, or pi over 4. All right, so the equation of the line tangent to the curve, inverse tangent of x squared at the point x equals 1 is point slope form, baby. Point slope form. Plug it in, move on. Your book, I don't think, uses point slope form. Y minus y1 pi over 4 is equal to m, which is 1, not necessary, times x minus x1. What form should you leave it in? You should leave it in the form that's, if they don't tell you, if there's like no specific directions, point slope form, plug in x, plug in y, move on. All right, you guys, that is section 4.3. Hopefully these examples will take you through everything that you need for the week. But otherwise, post questions on Classroom or come to office hours. Stay cool in this heat.